Since the dawn of humanity, we've had a complex relationship with nature. We're obviously a part of it, but often we view ourselves as separate from nature, or even working against it. Through the control of fire, the rise of agriculture, and the growth of our civilization, we've been molding the Earth's environment to suit our needs.
We try to control it, we try to protect it, we depend upon it, and we try to understand it. But could we recreate it? Taking what we know about the planet and what we need to survive, could we replicate the Earth's ecosystems?
Well, back in the late 1980s, a group of scientists attempted to do just that. In the middle of the Arizona desert lies a 3.14-acre research facility that was designed to mimic Earth's complex natural systems. This cool-looking giant greenhouse building is known as Biosphere 2.
Okay, but where's Biosphere 1?
That's a great question. That's one that we're commonly asked. So, Biosphere 1 is the Earth.
This is John Adams, Deputy Director of Biosphere 2, which is currently owned and operated by the University of Arizona.
Biosphere 2 was really thought up in the early 80s with this notion that there was a lot of discussions about space travel, extended stays in space, and the recognition was how are you going to do that?
In 1987, a private organization, Space Biosphere Ventures, headed by billionaire and environmentalist Ed Bass, spearheaded and designed the construction of Biosphere 2. The project hoped to demonstrate the feasibility of space colonization by recreating the Earth's ecological systems inside of an artificial habitat.
Inevitably, you would have to take some of these biological processes that we're so dependent here on Earth for into space and balance what happens between them to support the existence of a certain number of people for an extended period of time. No one really had tested that on a large scale.
And Space Biosphere Ventures would attempt that. They intended Biosphere 2 to be a completely closed, self-sufficient system, like the Earth's own biosphere, where plants, animals, and humans could live indefinitely. In fact, it was the largest closed system ever constructed, and one of the most ambitious and complex Earth science experiments ever conceived.
And for the most part, they got it right.
In September of 1991, 8 people were sealed in Biosphere 2. Known as Biospherians, they would live inside the structure for a full 2 years. All their food, water, and amenities had to be obtained from the habitats inside the biosphere. They were to have no direct contact with the outside world for the entire length of their stay. And almost right away, things started to go wrong on Biosphere 2.
And one of the first things they began to notice is that oxygen began to go down and down and down. About halfway through this first 2-year mission, it got so low that they had to add oxygen in because they were concerned for the safety of the individuals inside.
This was a problem. The introduction of outside air defeated the purpose of the closed system that Space Biosphere Ventures was trying to achieve. This, along with the perception that management wasn't being forthcoming with their problems, led Biosphere to be losing credibility as fast as it was losing oxygen.
They were very heavily scrutinized by the media and the press, and as they say, the wheels came off the wagon at that time.
Along with the oxygen loss, Biosphere 2 experienced a number of other problems, including massive plant and animal die-offs. The Biospherians had difficulty raising enough food to feed themselves and were constantly hungry. This contributed to morale problems, causing a rift in the group, splitting them into 2 factions, and these problems, along with the abrupt resignation of the project's scientific advisory board, seemed to confirm the view that the biosphere was just for show and not actual science. A second mission was attempted in March of 1994. This second crew was able to fix some of the problems the first crew had, but because of management disputes and dissension among the crew that culminated in 2 Biospherians sabotaging the closed system, the mission ended after only 6 months. Biosphere 2's managing body dissolved at this point, and with its original purpose seemingly invalidated, the fate of the project was uncertain.
Jeez, it seems like they failed big time.
A lot of people like to say because of sort of this initial falling out and loss of credibility that it was a failure. And no experiment is a failure. And that's what this was and is it's an experiment on a grand scale, had never been attempted before, and the engineering is absolutely amazing. But what they did learn, and probably, in my opinion, the single most important lesson, is really how little we truly understand Earth systems.
Biosphere 2 was designed to contain 5 biomes or habitats: a rainforest, an ocean, a savanna, a mangrove wetland, and a fog desert, along with an agricultural area and living quarters. Although people don't live in the biosphere anymore, the ecosystems are still thriving and have been growing for over 20 years now.
So we're walking through what we call the lowland of the rainforest, and you know, the rainforest is a pretty cool area. I mean, if you can believe it, we're standing in southern Arizona, but look where we're standing.
Yeah, this is amazing.
So all of this growth that you see, has taken place over the past 23 years that this system has been growing and establishing.
It looks like you're running out of room. The trees are hitting the ceiling now.
Oh, they are. And one of the things we periodically have to do is we have to go in and trim those upper canopy trees. Now, I think the most important thing for people to remember is that you can never recreate Earth in its entirety. It's impossible. There's just too many complex things. Really?
Dang it, let's get out of here, guys. No.
But what you have now is you have plants that have been growing for about 23 years. You have a soil column that's confined and isolated from the outside world. So underneath all of Biosphere is a big stainless steel liner. So there's no exchange or interaction with the desert soil outside. So all of this is evolving and able to grow inside of this system with very little influence from the outside.
Oh yeah, it's warmer.
So you could feel, I mean, almost an instant humidity change.
Yeah. Oh yeah, the fogged up camera lens.
So every rainforest has to have a waterfall and a pool of water, and we'll walk down and we'll see our stream.
Okay, cool.
So this is our ocean.
We going swimming?
We are. Ready to go scuba diving? The tank itself is about 1 million gallons. By the time you put in the rock and the sand and everything else, the volume of water is just under 700,000 gallons.
Cool. Seems like, it smells like a beach. We're on the beach.
It's pretty nice here. I mean, what a huge change from, you know, sweating in the rainforest and the humidity to something that's pretty cool.
This feels like a nice, great, a perfect day. Like it's nice and cool, not too hot, on the beach. It's great.
No, in order to achieve these environmental conditions, there is a suite of mechanical equipment that sits below us in a basement-like space that we call the Technosphere. Biosphere itself, the footprint is a little over 3 acres, and you have almost 2 acres in this Technosphere space where we have these big units here. These are our workhorses. These are air handlers, so they circulate the air as well as condition it. Up above, we can see all kinds of pipes that are running. So these are going to move water from one location to another, electrical lines, pumps, motors, but it takes all of this to recreate that which Earth is doing every day for us.
In addition to controlling airflow, there's another major issue that the Biosphere designers had to consider. Biosphere 2 has a volume of 7.2 million cubic feet. As a closed system, it's designed to lose very little of the air it contains. But Biosphere 2 sits in the middle of the Arizona desert and is subject to large temperature changes from day to night.
You heat the air up, it expands. It's got to go somewhere, and it's the only way it can go is to push out on the glass and eventually create enough pressure to cause an explosion.
Kablooey.
Or at night, as it cools enough, you can have greater external pressure than internal, and you create an implosion.
Backwards kablooey. To remedy this problem, Biosphere's engineers had to help the facility breathe, so they gave it a lung.
A lung?
Yep, a gigantic 40,000-pound lung.
So you feeling strong today? Did you have your Wheaties this morning?
I didn't.
Okay, all right.
I had coffee.
We'll see if this will work for you then.
Okay.
So we're in one or two of these geodesic domes. Inside of that is this large diaphragm. So this aluminum dish here weighs about 16 tons, okay? The rubber membrane weighs about 4 tons. Wow. So combined weight is about 20 tons or approximately 40,000 pounds.
Oh my God.
And so what happens is the air expands inside Biosphere, it's gotta go somewhere, it comes in here, path of least resistance, it pushes this up, and then at night, this weight pushes down on the air and pushes it back inside Biosphere. So by this structure going up and down, it regulates air pressure inside the facility, all while keeping the pressure relatively constant. Wow. And the reason I asked you if you had your Wheaties is, so if we grab this, we can pull down and you and I can move 40,000 pounds.
Whoa! That's awesome.
And all that's holding this up is differential air pressure. There's no crane, there's no hoist, there's no big winch that's moving. And so this thing will just go up and down, it just oscillates.
That's amazing.
Okay, that's pretty sweet. But what do they use the Biosphere for these days? Are they going to seal in another group of people?
Well, no. At least there are no plans right now. If the original Biosphere 2 missions taught us anything, it's that there's a huge blind spot in our understanding of Earth. So since the end of the original mission, the facility has been used as a gigantic Earth sciences laboratory.
So we can learn about those blind spots.
Yeah, most Earth science experiments are done on a very small scale in beakers and small lab setups.
Not always a great model for something as massive and complex as the Earth.
And the only way to test Earth systems is to use the Earth itself.
But that must be pretty hard, if not impossible, to control all the variables.
But Biosphere is this intermediate step where you have these established biological communities, and you can come in and say, hey, I want to increase the temperature and look at how the system behaves, or I want to cause a drought, or I want to change the atmospheric concentration, whether it's CO2 or some other gas, and look at collectively how this whole system responds. And there's no other place in the world at this scale that you can do those types of experiments.
Some of the earliest research at Biosphere focused on manipulating CO2 levels in the atmosphere.
To model projected CO2 levels in our own atmosphere and see what happens.
So we've heard about carbon dioxide going up in the atmosphere, and we hear a lot of the debates centering around how that's going to change the temperature of the Earth. But one thing we know for sure is that as you increase atmospheric CO2, it's a gas that's soluble in water, and what ends up happening as it diffuses into the water, it begins to lower the pH.
This is called ocean acidification. It was theorized for a long time, but was first demonstrated on a large scale by researchers from Columbia University at Biosphere 2.
They were the first institution, the first research institution to really manage Biosphere and sort of kick the tires and see what it could be used ecologically.
Increasing the acidity of the ocean environment in Biosphere 2 had detrimental effects on the growth of its coral reef.
And this doesn't bode well for the Earth's oceans if this happens to them, since coral reefs provide a habitat for a quarter of all marine species on the planet.
At this moment, the University of Arizona is getting set to conduct the world's largest Earth sciences experiment at Biosphere 2.
The world's largest?
The world's largest. It's called the Landscape Evolution Observatory, and its main purpose is to study how water flows through soil. They built 3 artificial sloping landscapes housed in a 5,000 square meter facility. It's pretty big.
That's a very wide water slide.
It is, and this is the top view, and a lot of people say that, is this the water slide or the ski slope inside Biosphere? But all kidding aside, this is the world's largest earth science experiment, and it took many different disciplines coming together to ultimately come up with questions. And what you see here, the design of this, we think of water as something that we understand very well, but a lot of the hydrologists will tell you that the principles that we use to describe its behavior, especially as it moves below the surface, they were all developed in the 19th and 20th century, and we're still using them today.
Because of our limited knowledge of how water moves through a terrain, it's very unpredictable.
We hear about it all the time. There's either too little water, for example, in Southern California, or there's too much water like Texas is getting. There's never this happy medium. And so water is one of those resources that is going to be most significantly impacted by, a change in our climate. But understanding its behavior is critical for us understanding, as it rains in the mountains, how much is going to end up downstream for societal needs.
Layer by layer, they'll build a replica landscape by first laying bare soil and then slowly adding plant life, so they can see how the flow of water through soil changes as you change the landscape.
The other really cool thing, and maybe it's not cool when I mention it to you right now, but we're standing underneath a structure that weighs 2 million pounds. Okay?
Let's get out of here.
Yeah. So, but it's on these columns right here, each one of them has a scale. And they tell you exactly what the weight of the structure is. And as you add water, you can see that weight go up. And as water leaves the system, you can see that weight go down. And what we can do is it allows us to mass balance the system. Where is every droplet of water going? And the hope will be is this will give us a better idea of the behavior so that we can make more informed decisions.
Biosphere's original purpose was to model what it would take to keep people alive in space for an extended period of time. Are they ever going to get back to that kind of research?
Matt, I'm glad you asked. The University of Arizona is doing just that.
How can we take what we learned in Biosphere and potentially create bioregenerative life support systems? Biosphere was extremely ambitious, and they tried to put in as much diversity and all of those natural systems that you find outside. Well, they quickly learned that it was very difficult to balance all of that. So the next generation, if you want to say, was to go with really a hydroponic setup. What you've got here now is a system that's growing and recycling nutrients, carbon, oxygen in a way that, in theory, could potentially support a person for 1 year.
This is how much would be needed for one person?
Yes. You'd start out with the appropriate amount of water, and then it would just recycle that water. It would eventually be able to recycle, there are components to recycle your waste, and to produce enough oxygen as well as caloric intake.
This is just a model, but the idea is that eventually a lunar greenhouse like this would be sufficient to provide all the food, water, and oxygen for one astronaut on a daily basis.
So we really now have a unique opportunity to leverage this one-of-a-kind world's largest earth science laboratory in ways that no one could have even envisioned early on. We only have Earth, and we're dependent on the systems and the processes. And so figuring out a way in which we're able to continue to have those resources and exist in a way that's favorable for us is crucial.
So what do you guys think? The Earth is a giant mystery. Will we ever unlock all of its secrets through experiments like Biosphere 2, or will it be forever out of our reach?
Let us know in the comments.
And we'll reach down there with our eyes and read those comments.
Yeah, and understand the complexity of your words.
Thanks for watching. If you like our show and you'd like to help it continue, you can go over to Patreon and become a supporter.
Last video, you went skydiving, and we talked about thrill seeking, and this is what you guys had to say.
After seeing me go skydiving, many of you commented that you now want to go skydiving. I can only attribute that to how good I made it look. I look good. But I think that's great. When the dudes asked me or made me go skydiving, I kind of wasn't really excited. I was nervous, as I said many times in the video. I thought maybe I'd go skydiving someday when I'm like really old, but I'm glad they made me do it because it was so much fun. It helped me get out of my comfort zone and into the danger zone. But it's not actually dangerous at all. I looked up the statistics. You're way more likely to have something bad happen to you in a car than falling out of an airplane with a parachute and a trained professional. One issue I had that I didn't mention in the video was the strap on my leg wasn't on correctly necessarily, and it had some bruising and it kind of hurt afterwards, but it was fine.
Flintstone and Sam Ram DeBest expressed some doubt about the number of jumps that Rook Nelson has taken in his life, which is somewhere above 22,000. Flintstone was saying that he'd have to do 2 jumps a day, 365 days a year, to be able to do 22,000 jumps in 29 years. In actuality, being an instructor, he does way more than 2 jumps a day, probably does up to 10 on average. So at 10 jumps per day, you can see how he could get to over 22,000 jumps. He also lives like there. He lives right next to it, so he's probably jumping all the time.
For some reason, Camilla N asked, how do vending machines work? Well, how do they work, Matt?
Well, I think the reason she asked was because a vending machine is basically a place where food goes to skydive.
Ah, but it doesn't have a parachute.
No.
That's dangerous living. That's dangerous
but
food
food
living.
isn't alive, so it doesn't need a parachute.
Well, some food is alive. You can,
Not usually the food that's in a vending machine.
I read somewhere, I think it's either Japan or Hong Kong, you can buy live crab from the vending machine.
Live crab?
Live crab, look it up.
Okay, well, do they have parachutes?
No, no parachutes.
Well, that seems dangerous.
It does. Good question, Camilla. Did we answer that question? I think we did.
Yeah, totally answered.
Thanks for watching. We'll see you next week.
Yeah, with an all-new video.
Second video of the Humans vs. Nature playlist.
Check it out.
Check it out.